injection of a global variable called input URL, and I'm putting my malicious content in it. So this time, when you execute the code, this malicious content gets stored in your Flash cookies repository. Now, it doesn't matter if there is some code here that blocks from the attack being happening, because it doesn't matter really if the attack would work now or not. The only thing that matters is that I was able to inject this malicious cookie to your browser. Now, the next time that you will step to the site, to the regular site, to the index HTML site that has the object tag and contains the Flash file in its original environment, that Flash file will take the cookie, the Flash cookie, and use it when it will try to redirect your browser. Was it clear?
Yeah, I think so.
All
right. Okay, so what's also important about this attack is that, as you said, it is persistent, meaning that after the first infection, the client remains vulnerable. Every time the client browses to that specific URL, the JavaScript code, for example, or the cross-site flashing attack will be executed. Also, because of that reason, the attack will be visible only to the server only in the first infection. After that, everything happens on the client side, so the server side is not alerted. It is invisible to the server. And also, what is important is that even if the Flash movie is later on fixed, the attack can still persist unless the developer can take specific measures to fix this specific attack, meaning not using these Flash cookies.
Okay, so let's talk about an example that makes use of some vulnerabilities we discovered in Adobe Presenter. So Adobe Presenter is a desktop application that allows you to compile Flash files and HTML files, and together with that create a web page that is very nice, very similar, showing a lot of time it is used for demonstrations, and then you post this on your website and publish it to the world. So let's look. So this is Adobe presentation. We didn't put any real slides here because we didn't have time to, but generally speaking, we have an HTML file, and that HTML file actually uses a JavaScript and a function called showFlash. Now, as you can see, this function is actually vulnerable to DOM-based cross-site scripting. This was actually found by Taviso Mandi from Google, and as you can see here, document.url is being used to create the string s, and at the end we have document.write_s, and as we all know, I hope you know, that a malicious user can send you a link with whatever payload he wants in the document.location. So let's try to do that. So putting the payload something like this, closing the object tag. Actually, you don't have to do that in most browser, and applying the script. And when the user will browse to this location, the script will get executed. So this is a regular DOM-based cross-site scripting attack. Now, the suggested solution for that was to use the encode URI method. And that actually protects you against DOM-based cross-site scripting. So if I'll save that, reload, you see that the attack doesn't happen. The script isn't getting executed. And the reason for that is that in encode URI, I actually encode the double quotes that I had to put in order to get out of the context of this value attribute. And I cannot get out of it, and I cannot inject my own scripts to that. So now we are safe against DOM-based cross-site scripting. Now, another thing that we have discovered is that the Flash file that is being used here, viewer.swf, somewhere here, is actually vulnerable to cross-site scripting through Flash. So we found several global variables that if I would be able to control them, I would be able to execute a cross-site scripting through Flash attack. Now, if I would like to load the Flash movie in its original HTML, What I have to make sure that the user will actually browse to that original HTML, but still I need to make sure that those global variables that you are trying to inject will get injected to the embedded Flash file. So as you can see here, this is very similar to this is actually exactly the DOM-based Flash parameter injection technique that we talked about before. So what I would do is something like this, and then I need to, so this is the flash vars attribute. So I'm sorry, this is very similar to the flash vars piggybacking. So what I will do is I would have to put something here that ends the value of initial URL. So I'll put the ampersand sign, and that will tell the Flash player that a new global variable is starting. And then I will put my injection. This is underscore URL. This one of them underscore URL equals JavaScript and some JavaScript piece of code. So what will now happen is that on the client side, this piece of HTML code will be created, and the Flash player will actually identify two Flash variables. One is initial URL, and the other one is the underscore URL. And overwriting this will allow me to actually execute the cross-site scripting through Flash attack. So let's see, and it works. Questions so far? Yeah.
So I walked in, I missed maybe the first 5 minutes. So somewhere in here, there's a protection against this stuff, or are we completely open?
Yeah. So what you have to do as a developer, you must make sure that you're encoding user input correctly. And as we see here, it's not sufficient to just use encoding techniques. The encoding method should be applied according to the context of where the input value is being reflected. So in some cases it will be encode URI, in some other cases we should use other encoding techniques that encode other characters, such as the ampersand sign. Because the ampersand sign is not encoded, then the Flash player thinks that there is a new variable definition here. If it was encoded, it would understand that all of this is the value of the initial URL variable.
Okay. And as Flash developers and subject matter experts, what percentage of the community out there of Flash developers would know to get this right?
So what funny is that a lot of time when we see Flash code, a lot of time it is being written by people who know nothing about security. We always see the copy-paste stuff.
Yeah.
So a lot of time we see code that user make use of global variables while they don't really need to do that. So they use the template that we shown you before. If variable is undefined, then define it. But actually there is no sense in doing that because they always want to use the same value. So they should have just statically defined this variable saying initial URL equals whatever they want. And by doing the copy-paste thing, they are creating more security threats into their own applications. So we mostly see that security is not a real consideration in many of the developers.
There are some attacks that were published, some of the attacks that we've talked about were published back in 2002, and we still see the same exact pieces of code in applications today. Attacks that were publicized for a very long time.
And we see that a lot of vendors put Flash ads into their websites. We've all seen that, right? And what needs to be remembered is that adding this Flash file into your website might pose more security threats. So you have to take that into consideration when you do that. So it's not just, let's take someone's Flash, it's someone else wrote it, I don't know. When you put it on your website, then it poses security vulnerabilities to your own website.
To your own clients.